Hi, my name is Shane Jansen, and my senior project was a prototype active aerodynamic wing for my personal vehicle, a Mazda Speed 3. First, a bit of a background on what active aerodynamics actually are and what they do. Active aerodynamics are made up of self-adjusting aerodynamic components of a car, and adjustments are made to these components based on speed, steering input, or braking inputs, depending on what the goal is. They're typically used to improve fuel economy and/or performance. They do this by decreasing drag, increasing downforce, and redirecting airflow depending on what their goals are. Typically, these systems are exclusive to high-end, luxury, and performance cars, much like the one seen below. This is mostly because of reliability concerns and cost effectiveness. My project goals are as follows. I wanted to increase the amount of downward force on the rear axle when the spoiler is in a down position. But I wanted to increase the amount of drag under heavy braking. The goal of increasing the amount of drag was to stabilize the rear axle under heavy braking and to force the rear brakes to do a higher percentage of the braking, because in normal driving, your front brakes are doing nearly 90% of the work. I wanted it to effectively function as an air brake. Other goals of the project were to keep it lightweight and keep it affordable. So why did I choose to go with active aero for my senior project? Well, I'm a huge car enthusiast and I was inspired by high-end luxury performance cars. Again, much like the one shown below. When I did some research, I found very few examples of retrofitted or custom designed systems like this. So I was excited for the challenge. I was able to apply many lessons that I learned both inside and outside the classroom. Inside the classroom, I got to gain knowledge on fluid mechanics and fluid flow, dynamics and forces, systems design, and many more things. Outside the classroom, some things that I taught myself along the way in this project was how to use composites like fiberglass, and I got to brush up my welding skills and fabrication skills, and also learn a little bit more about basic electrical. I faced a lot of challenges on the way. It all started with modeling the car. I found that a lot of the 3D models ended up costing well beyond $100, at least for an accurate model. The only model that I could find that was completely free of charge was this model shown here. This was a SketchUp file that unfortunately was not able to be imported into SolidWorks and used for flow simulations. Another challenge was choosing materials. I really wanted to use carbon fiber and aluminum, but those things are very expensive. So instead I went with fiberglass and steel, which unfortunately resulted in an increased weight, but definitely saved on cost, and it was easier to fabricate. Everything that this system was made out of needed to be weather resistant. All the steel parts were primered and painted to coat them and prevent them from rusting. The linear actuator, the only electronic component of this assembly, needed to be waterproof as well. It would be exposed to the elements out in snow, rain, in the hot and the cold. My car is outside 365 days a year. The device I went with is rated IP65, an ingress protection rating of IP65, which allows for it to be used outdoors. One of the goals was to have rapid actuation. I really wanted the spoiler to go from its full upward position to its full downward position, and vice versa, in less than 2 seconds. Unfortunately, that was kind of tough to do because linear actuators are a balance between force output and speed. So I found linear actuators that were really slow with a high force output, and linear actuators that worked really fast with a very low force output. I ended up going with a slower linear actuator just so it can cope with the forces that would act on a wing. I used a couple different materials for this project. I used a 6-ounce woven fiberglass cloth for the center section of the spoiler, which was wrapped around a polystyrene foam board insulation that I got from Lowe's. I used epoxy resin on fiberglass because you cannot use polyester resin as it will dissolve the foam. I used 1/8-inch steel plate for some of the brackets and for the end plates of the spoiler. For the wing inserts that you see pictured here, they are PLA 3D printer filament and linear actuator, which was mostly made out of aluminum, And all the hardware was either aluminum or stainless steel just to prevent corrosion. Next, I needed to do some calculations. First, I found the coefficient of drag via SolidWorks flow simulations. This allowed me to calculate the drag force using this equation here. By finding the drag force, I was able to figure out what forces were acting on each of the members throughout the assembly and figure out how much force needed to be put out by the linear actuator. Unfortunately, I didn't get to test the assembly until a little bit later than I had hoped. Some of the components arrived kind of late from shipping. First, I did some stationary testing just a few days before demonstration day. Everything functioned as expected for about 3 cycles. Then, on the 4th cycle, during an extension of the linear actuator, there was part failure. The failure points were recognized as the mounting bracket on the underside of the spoiler, where the hardware had stripped out the fiberglass and pulled apart. While we didn't have another failure point, we did see some issues with the ends. Where the hinge mounts were, it was pushing them outward. I believe that the issue was that the linear actuator was pushing too much force towards the rear of the vehicle rather than really pushing the spoiler upward. Now that I've done this, it's been a massive learning experience, and there's a lot of things that I'd like to change in the future, because this definitely won't be the last time that I work on this project. Some of the things I would change are the manufacturing methods. I'd like to make a mold for the composite parts, just to ensure a smoother surface and more consistency. I would CNC the end plates, just to make sure that all the holes are perfect in the right locations, and to make the parts look neater. Some of the dimensions may change just to increase the effect. I might make the part wider or longer, just to get a little bit more drag and a little bit more downforce out of it. I would explore different mounting methods. While there were different mounting methods considered for this project, I chose this one because it was the most compact and neat looking setup. Unfortunately, it did not work as well in practice as it did in SolidWorks. I would change my linear actuator choice. I would see if I can custom order an actuator that had a better balance between speed and force output. I didn't need the massive force output that this linear actuator had, but I needed more than the faster linear actuators that were available to me. I'd also like to increase the amount of control that I have over the angle of the spoiler. In the future, I'd like to do this with maybe an Arduino. This way, I can change the spoiler position, its angle, based on how fast I'm going, and so it doesn't have to actuate when I'm just driving around town doing 20 miles an hour coming up to a stop sign, because it looks kind of silly. Before I end off, there's a few people that I need to thank for helping me get this project done. My friend Trevor, who helped to 3D print some of the parts that I needed for the wing hinge points. Bradley Supply in Hornell, who helped me figure out what materials I needed and were able to supply them to me for a good cost. My father, Scott Jansen, who of course helped me to fund this whole entire project. The Alfred State Motorsports team down the road, who allowed me to use their shop space, some of their tools, and even helped me to get some of the things welded. And last but not least, my senior project advisor, Professor Murat Al, who was steering me in the right direction the entire time and helped keep me on track and answered a lot of the questions that I had throughout the way. Thank you so much for watching my presentation. If you've got any questions, I'll go ahead and put some contact information down here in the description, and feel free to reach out to me. Thank you.